Is that a release? I mean, normally it's row column. Yeah, it's like this. Oh yeah, Junkie Games. Yeah, I'm great. It's a bit weird that this thing starts counting as 1. Yeah, I don't know. I'll leave it like this. You transform light must represent an affine transformation matrix. Look for that. It must have a member, a member, member function. That would be for this one, so we get the scale from there. Oops. Yeah, loads of stuff, man. Oh yeah, uproar. Diverted. I'm using Arch. I have a map. A stupid image. Just caps lock. We think you transform multiplies from the left, I think. relation x, y in there. Okay, I'm confused. If the translation goes here, then that's not 0. I think in our case, I think these are from multiply from the right, and I have it multiplied from the left, so there's it probably just at the bottom here. So transposed or something. I think it's like this. Yeah, that should allow me to figure out actually if it is multiplied from the left or the right by simply doing it. For example, if we multiply this thing from that side, then we get no, let's see. So to get this element, we have to multiply this vector dot product with that vector. That gives us just M11, so that's indeed M11. And then for this element, or that element, you have to multiply with this this thing in the middle here to get M12, yes. And then the last one is going to be this 0 here. And here we get 2, 1, and then 2, 2, and then the 0, right? Well, no, wait. This one times that 0. And now it finally gets interesting. Then this becomes that would be M11 times dx. Plus M22 times dy. Plus and a 1 at the end. Wait a minute. The first one here is... That's a 2, 1, sorry. Plus 3, 1. No, that seems consistent with say that we begin with the identity matrix. It means that MII is 1 and MIJ is 0. So then we get dx here and dy here. And the M31 and the M32 just remain, which would have been the translation to begin with. Dus you get the old translation plus the new translation, which is okay, well, that should work. I'm gonna ask the AI. I'm too lazy to do the other one as well. Could try to multiply it from the right and then see if it gets nonsense or not. Maybe I should just do that, you know. Okay, so this is that column times that. Why is it so difficult? It's M11. Yes. This one becomes M12. This one becomes 0. This one becomes M21. This becomes M22. And that one is 0. And then this one becomes M31. M31 plus dy. Actually makes some more sense. That makes more sense, right? The fact that this is multiplied by a matrix value is actually not consistent with what you would expect. This would be this element here would be this one times that one. So 1 times M31, that's the M31. And then 0 times that, and then the x times 1. Yeah, this is the one. So this is just the x plus M31. Actually, way more logical. And then this should, of course, be dy plus M32. So we get this one, 0, and the 1 times M32, and then the dy. Yeah. And then the last one, I believe it's going to be 1 again. Yep. Okay, so actually, this is wrong. It is this one. And then on this one, of course, also multiplies from the right. For the scale is just SX here and SY. Yeah, they call it C, but whatever. And that then gives us, well, this, but then scaled. How does that look if you scale it? Well, just calculate it. It is SX times M11. Those are 0, so that's the only thing here. And then here we get SX times M21. And SX times M31. And then here we get SY times this column. Yep. And then this multiplies with this, but then I think transposed. So and anyway, the cosine is there. Cosine phi. Let's use phi. Why not? Use a phi. Is that phi? It's not phi, man. That's theta. Cosine theta, and here we have another cosine theta, and then we have a sine. No translation, so this is 0, and this is always 0, 0, 1 vertically. So, and then we need a minus sign in front of one of the sinuses. So it's going to be that one. So it is just composed. Dude, that is 1, 2. And then 1 down, we get that times that. So the first one becomes a 2. The first index. Now we get M22 here. Stuff. Same thing, but in M3. And here we have the same thing, I guess, but the sine is and the cosine is flipped and the minus sign gone. I'm just gonna copy that like this because it is the same thing ish. Copy, paste, and then this is a plus sign. And then the cosine must become a sine. Can I do a substitution like this? Because it's probably the whole line. Yeah. I don't think that works. Okay, just cut and paste it. Oops. So. So the last one then is again the same thing, but then not sines and cosines, but 0, 0, 1, which means this is 0, that is a 0, and the 1 is multiplied with the M13, which is 0, so that's a 0, as expected, it should be. And here too, and here you just get the 1, this 1 times that 1, and the rest is 0. So. Very good. Well, the problem with the LLMs is that you have to check what they say. Can't really rely on it to be correct. So I might as well do it myself then. P. What the hell, man? Nobody gets this. No, we have it. Inverted. Yeah, I have absolutely no clue how to invert a matrix. Let's just write it down as inverted, you know. Okay. I think there is some kind of trick to it. As in, if you assume that you know the determinant. Okay, I'll ask an LLM what the inverse is. Well, I do have the inverse here, do I not? Shear scale. They're going to tell us what the inverse is. Yeah, I don't think so. Yeah, I don't have that. Oh, well, actually I do. Determinant, I think. That is very strange. How the hell does M11 end up here? I don't believe it. Nah. It's like a transpose, maybe a minus sign here and there, ish, I don't know. But yep, I don't know. The only thing you can do is, hey, Cotarino. No, the transpose divided by the determinant. I just don't understand why M11 would be end up here. That makes no sense in my eyes. I think that has to stay there. On the other hand, if we multiply this with M11, M21, M31 vertically, we get, for the first thing, M11 times M22 minus M21 times M12, which is exactly the determinant, and then divided by the determinant is 1, which is what you indeed want. So maybe it's correct. Maybe it is correct. Oh, okay, so I was mistaken. These two just swap, apparently. A and D, they swap. And here we get minus signs. For a 2 by 2 anyway. And then divided by the determinant. Well, in that case... over there. That's what it did. So the M12 and the M21, they stayed where they were, and these and with a minus sign in front of it. And the M11 and the M22 were swapped. So that's what it says here. So it's the usual 2 times 2 inverse. Okay, I'm just gonna believe it. I won't use it anyway, just for a comment. So might as well call it the day. Can I copy paste this? Probably not. Nah, I cannot. Okay, I'll have to type it over. So this returns 2 here. And a 1 here. Oh, hell. And then a minus sign here. And a minus sign here. Sure. I'm just gonna write that here. M21, M32. Minus what was it? M21, M32 minus M22, M31. M22, where's my M22? M22 times M31. And here we have M12 times M31 minus M11 times M32. I think this just multiplies from the left. That's a weird thing here. It's not like a normal matrix multiplication. This a Q transform. It multiplies from the other direction. I have a new keyboard. Can you hear it? It makes way more noise than the other one, than the old one. Can I make a picture? Let me make a picture. I can show you. Trip picture. Share. Whoops. What? Share. Nothing. Okay. So don't put it there. Just send. I don't even have it running. Yay, my desktop. So this is my new keyboard. This is not the old keyboard. This is of the second PC. There's a monitor above this monitor. I guess you'd make a picture of the old one as well. That is just a Microsoft Sculpt. So that sounds like this. Microphone return. So this is the Microsoft Sculpt compared to the new keyboard. Makes a lot more noise as it. So I can make a picture. Yeah, I should have made the picture right here immediately. Where is the camera there? The Sculpt. So that was the old keyboard. And as you can see, I don't, both keyboards, this one and that one, they're almost the same. They don't have a keypad on this side. So you can have the mouse much closer. A keyboard like this is horrible. It's like enormous distance here that you have to move the mouse further to the right. I hate that. Plus, yes, there's a hole in my table. I made this table myself. Go back here to the other one. So this is the table, and there's just a hole in it. And the keyboard is on a piece of wood with a thickness of, I think, of 2 millimeters at most. This is 2 millimeter thick, and it is on rails. So underneath the table, there's a rails here, so I can just move it back and forward. And yeah, the main reason I made it like this is that this is so thin. So there is very little space between my arms and my legs, like this. So you can have your arms lower. Okay, back to the comments. So the map I think is multiplying from this side. So I'm just gonna let's make a vector or something here. Dip, P. I guess this is. It's a very good question how we do that. Is it not just XY1 or something? I think so. Yeah, it's a nice place, man. You should see the whole desktop. It's that table there, so basically 1, 2, 3, 4, 4.5 square meter in total. You can put up to 6 monitors here, but I never did that. And a large part is for electronics, actually. Not all computers. I have a simple computer. Just, I don't know. I forgot. I have 16 cores, I think. 16 cores, 32 threads at most. No, put together myself from separate parts. I picked them. I pick each part. I'm not gonna buy a complete computer. I don't know what COM16 is, but dude, why all the questions? Proc CPU info does not exist. Oh, that's new. CPU info. Oh, I typed that wrong. Oh, God. So this thing is an AMD Ryzen 9 3950X 16 core computer. I wouldn't know. Okay, how do we multiply this thing? It is not possible. What? It's not possible. It must be a row vector, otherwise you cannot multiply it. So yeah, let's write it as an x, y, z. Left and y here. Okay. Get out another row vector. Let's see how that works then. That is just x times this thing here. Okay, it's just x times the sum of this. No. I call it epsilon plus y times that plus z times that. There is no z. What the hell, man? That is a 1. So just plus that. That is a translation. These things are the translation. So this is the x translation. So we just add it to whatever the x coordinate is. Yeah. And here we get x times that plus y times that plus that, and then this thing times that thing is just 1 again. The persistent 1. Might as well give it another indentation. This is Qt. It's how Qt works, but we have a class here, Qt transform affine transformation, which you can pass something that is as a template parameter that is either Qt or Q transform or Q transform like, and then it converts it into an interface that my transform class needs. So this is the find transform backend basically for if you want to use Qt, and yeah, it hardly does anything. I mean, it just calling. I mean, this is translate, and then it just passes it on to the Qt thing. This is now Qt transform. So you call translate, and calls translate directly on Qt transform. Scale, same thing. Rotate, same thing. Inverted, same thing. Except you have to get rid of the OK that we pass here, because I don't pass OK back. Maybe we should assert here that OK is OK. Yeah. Well, we have it anyway. So. Yeah. That makes a copy-ish, does it? This is the return thing. There is of course copy elation for the return. So it's not like you construct the thing and then copy it again. You just the stack of the caller contains the return matrix, and then we build it in place. But we have inf. So inf is being copied to the stack of the core where then this return value matrix is. And you would wonder, why would I do that? Well, maybe optimization will get rid of it, because theoretically you would say, well, if I know exactly how this thing works, then there is not much reason to make a copy here and then copy it again to the caller. But yeah, well, if you do that, then we cannot check the OK. Dubious, I would say. But I think that Qt for Qt transform is Q transform, right? It's not no T there. Q transform itself is hopefully header only. Yeah, nah, I don't know. But if it is, then the compiler should be smart enough to see that there is no need to call the constructor. Normally you can, I mean, for some random class that you don't know what the constructor is doing because it is implemented outside of the header, you just have to call it. It's not always allowed to say, well, a copy constructor is probably doing nothing except copying. That's definitely not allowed. You have to assume that it has all kinds of side effects. So in that case, it would construct this thing. This is just a Q transform, or rather, I don't like auto. It's so unclear. So this is the type of transform itself. That would be this one. I'll just put that there, so way more clear. And then it's constructing it like that. But yeah, this is the current class. That's the current class, and we're calling an explicit constructor. That's why you have to, well, mention it here. If you just try to return inf while you need that, that would be an not explicit constructor, implicit constructor. It would have to convert this to that, and it doesn't want to do that because there's an explicit here. Well, okay, this just overrides the explicit basically. It doesn't do much for the rest. So it's going to call this one, and that is just a copy constructor of the only member that it has. So a little bit smart compiler is going to say, well, this thing is exactly that thing in terms of memory layout, and we are copying it, but then afterwards we copy it immediately again to, you know, the final destination of the stack of the caller, this return value. So let's do that directly. So I think in optimization case we are not having this, not going to have this variable. but only if the compiler can see what exactly is going on. So it must be that type, which is QTransform, must be entirely, or at least the copy constructor must be entirely inside the header. But I think that it is. I mean, that would be kind of crazy if they wouldn't do that, right? In terms of wanting to have this kind of optimization opportunities, they should put that in there. In other words, if you compile this with optimization, then this class adds 0 assembly instructions. So it's just a wraparound QTransform. And in the end, it's just exactly the same as if you were using QTransform directly. Map point here calls map. And then, yeah, again, we have something on the stack here, which then afterwards, after it's being filled, is casted to a double, which hopefully doesn't do anything because scalar is equal to a double. Cross fingers. And then that is being copied then again to the stack of the caller as a copy elation thing. So yeah, compiler optimization, hopefully, you know, it will just write directly to that memory location from here. But that would require, because you have to pass this by, well, if map is even defined in the header, then of course it's maximum optimized. Let's say the map would not be in the header, then, well, then it would have to pass the pointer to the memory location of this standard pair instead of going through that. You would almost be inclined to do it like that, and I think I would. I had this written by an AI, by the way, so yeah, it's not entirely my code. That's why I go over it, and I think that what I like to do is usually if I have some return type and I want to have copy elation, I just immediately begin with declaring that thing, and then I call that a result, usually, and then that's it. You know, the compiler now is going to understand. I mean, we return the result, right? So the compiler is definitely going to understand that this thing doesn't exist. This is what is being returned. So this is just, you know, whatever is being passed from the caller as being the memory space on the stack of the caller, where the result has to go. And if then we pass a pointer to the result first and a result second, because it's a pair, then we definitely are passing now pointers to the memory location where you want the result to end up in. But maybe the previous thing, which was of course way better readable, did do the exact same thing after optimization. So at most, using a pair here is, yeah, nobody, yeah, now we use first and second instead of X and Y. Ugh. But yeah, I don't know. If it is bug free, like this is bug free, of course, it just works, then you never have to look at it again. So then it's not that important if it says first or second or X or Y. And here we have the same thing as again and something that is returning that, but now we are constructing it. So we might as well do that at the end. There is not really anything that we can construct it in place, as it were, like here. I'm assuming at least that it is the case. We have to calculate this X and see how this works, by the way. It's we just do auto const. Well, const is not even necessary, but it can, well, why not? You're not changing it afterwards. And then we use square brackets, and then we assign that from the map point. That's how you can take apart the pair. Yeah, this map point here is this thing. It returns a pair, but then if you assign the pair like that, then this is first and this is second. So we don't have to deal, the caller here doesn't have to deal with first and second, it just gives them a name. So now they are called X and Y anyway. Now I want to understand, even when I started writing the comments in this file, I wanted to understand what the map vector is exactly doing. Yeah, because 0, 0, you know, what, why, and well, we have to probably begin with map point. Already did that. Map point is just doing a conversion, did full conversion of X and Y. And here we call map point twice. Is that really necessary? Let's see what I had before this. To the map vector, grab sources, map vector is being used. Well, in transform, this was the previous file that we were looking at. It's another implementation. Probably this is what we want to end up with. Yeah, okay, that makes it clear. So this is the map point. And then you get that. Only caring about the X and the Y coordinate. And this is the exact same thing, but then with no translation. That's the difference. So the M3, 1 and 2 are the translation. So we just set those two imaginary to 0, and then they drop out here. So if you return this, then it is as if the matrix had 0 at M31 and M32, which means there is no translation. Now where is map vector being called? Yeah, here, it's also hardly interesting, I think. Multiply from the right with stuff, with the size, so the size uses map vector. Okay. So I think this was changed because this is this member function is new. So you have to look at the diff and then specifically to that function, I think, and see how what that was. Git diff is escape, seriously. On the right with that point. No. The size one, this one. So this used to be super short. Super short. And then the AI changes it into this. Feels less short, as it were. Except, of course, if this is in the end optimized to just returning those matrix elements. So we're going to ignore the matrix elements M31 and M32. And the M something 3 is 0, 0, 1, so we never use those here. Good night. 0, yeah. What is this doing? Is it not returning this square plus that square or something? I forgot. How horrible. I forgot what this is doing. Oh, actually, it returns the square root of that. Oh, it just stands for hypothesis. This thing. What? You know, they have a triangle, and then the long diagonal side is called hypothesis something. So it returns the length of that. Basically, Pythagoras. Okay, yeah, well, I guess I'm not convinced actually. Why is it that? Go back to that file that I just commented. Okay, I suppose that is something like to extract the SX, the actual scale, you have to assume that M11 and M21, if not scaled, are 1 if you square them and add them, because that's just cosine and the sine. So cosine squared plus sine squared is 1. So what you do is we square this and then we add that to that squared, and then we get Sx squared. Then you have to take the square root of that, and then you have Sx. And this is assumed to be 0. So yeah, we do need access to this element, and then we can call the standard hypos on it, and here as well. And the AI thought, let's not use any other accessor than the thing we already have, namely map point. But I think I disagree, because it already used M11, so all the others are going to exist as well. Pretty much. I mean, do one thing or the other thing. it gets a scalar from M11. So M11 must exist. Dude, why not M12 and then an M21 and M22? So I'm going to extend this to demand that those must exist as well. It must have the member functions M11, M12, M21 and M22 that return respectively what was it? M12. Okay. I mean, we're already demanding that M11 must exist, and I don't think this is any problem whatsoever. A direct matrix element accessor. Doesn't get any cheaper or simpler, if you ask me. Okay, so let's add them at the top below the constructor. So it's going to return a scalar called M11, const obviously. Return transform dot M11. And then while we are at it, we might as well add 3 in case anyone ever needs it. I mean, it's either that or just add an accessor for the underlying thing. And we actually do have that, the underlying thing. So yeah, maybe not yet. If someone really needs it, then they can just get on the underlying thing. It has an accessor for it. They can use that. I'll call M32 on it, 31. Now I think about it. We need these. I don't need accessors for it. I just want them to exist. Let's not add this actually. No. They must exist, but yeah, I don't need accessors for it. And then I'm going to do the map vector, I think, a little bit more straightforward. Oh, which one was it? I think it was map vector. Vector should be this one. And yeah, I think that the other code was actually just would result in the same assembly after optimization. But yeah, why take the risk? This is a shortcut. More to the point, if you ask me. see, translation is removed. I'm so confused now. There was a hypoth that you needed a hypoth somewhere. Where the hell was that? Yeah. Oh, that's in transform itself. Okay. Yeah, well, in that case, we are going to need those accessors. So I want to have a look at that. Hello, Nasir. I want to use this. Where m underscore is, I think, my backend class. Yep, it's the backend class. So now we do need these accessors, and then indeed only those four apparently. Yeah, we don't have to do that anymore. This is not that. This should then lead to a div that looks more like it was. I think that these were the only ones, right? So git div with transform.h, new code, and then so the query is replaced with double, and there is an extra affine transform backend template parameter. Well, the rest is hardly anything is changed. Here's some comment changes. Here's another one that I don't like. So I want to get rid of all those map points stuff with constants. I really don't like that at all. So you have to look at this one. This whole code block should go. Oh, that's an easy one. M11 is just it should just call M11, and so on. And TX is yeah, it's a translation thing. So that's 3132. And we even print call M13, but yeah, that's going to be 001 always. So don't really need accessors for that, because they should be always have those values. I just add accessors for all the way up till the M3. But okay, I was looking for the div with the hypothesis. How the hell do I pronounce that? Sorry, I want to know now. Hypothesis. I'll type triangle to help help a little bit. These results are for that. It's called hypotenuse. Hypotenuse. Now you want to know how to pronounce it. Pronouns. Yeah, thank you. Hypotenuse. Say it again.
Hypotenuse. Hypotenuse.
Hypotenuse.
Hypotenuse.
Hypotenuse. Difficult. Hypotenuse. Or hypotenuse. Standard hypotenuse. Hypotenuse. Yeah. So no change whatsoever. Just the Q reel is changed into a double. That's how what I want to see, right? This was already there. But okay, let's improve this one then. You can also completely get rid of these calls here. No, just printing. So who cares how slow it was? I have to call this on. What was it? I keep back m underscore, right? M underscore dot. M underscore dot. Oh no, I broke it. In instantiation something required from print on required from. There's no name member. Oh, it is added. Not sure what the class should be now. Well, definitely this one should have it. Not sure if that is enough though. Let's add them back. I also added them here. Scalar, and then everywhere else it uses double. Why not just pretend that this is double? This is a double here. What's the scalar being used for anyway? It is being used. Does it be cost? Really? Yeah, well, I want to return a double. So how do we do that? There's nothing that returns doubles here. Yeah, here actually. Read the result. Oh boy. So passing a pointer here to a double. Well, it should have been a pointer to a scalar and then cast that stuff. I'm a naughty me. So this change is incorrect then. Except that scalar is a double. That's why it will compile. But yeah, it's not really super correct, I guess. Okay, I'll change it back. This was, what was it? Map point. Yeah. I'm just gonna call it X and Y maybe. Or do I already have an X and Y? X results and Y results. Return XR, YR. And then we have to cast it here. Well, I don't have to cast it. Just it's being automatically being converted. Why would I need a cast? Even if it's either a double, it's probably a double, or it might be a float, which I would really get upset about. If I pass a float to a double, it's not going to complain, I think. So. I don't think there's any cost to doubles here. It's pair double, no cost. Okay, well, I'll leave it like this. And then we have the accessors. So the accessors are going to return double. And 1 transform dot M1. Row 2 and 3. And then the same thing with call being 2. That's it. I have no recommendations, no. Yeah. So it still does not exist. Probably because M1 is what type? Fine transform to D. Okay, I have to add it there as well. This one is defined in transform. And yeah, accessors. No constructors. How horrible. Where are my constructors? These are kind of constructors because they return something static, or they are static, I mean. The static functions to do stuff. This is my constructor. So I want to add it here. Double. Because they are doubles, yes. Undo redo ZZ. M11 const return M11 underscore. And here as well. Oops, what am I doing? How do I manage to swap the 2 and the 3 there? Continue. Yes. More accessors. More matrix elements accessors. Deja vu. Now the interesting part is, apart from quick test, that it's still nothing has changed. Single. Oh, wait, what am I running? Okay, this one as well works. And did I not have something else here? The bounding bar. I wanted to run this because it is way more interesting. A single point which we can drag around. Awesome. Totally works. Okay. Let me think. Yeah, that would be interesting probably to compare my documentation here with the other backend that is defined here. So this documentation, which we cannot remember, so I'm gonna copy it temporarily. Maybe actually it should not be here. This is an implementation of something. Now we have so many, I don't want to list them all. IJ, yeah, doesn't look like it. Probably should add it to this concept. How do we do that? We just want transform M11 to exist and return something that's convertible to a double. Hash. And then 6 times. Type requirement is not a type constraint. That must be standard same as. Standard same as double. Well, maybe not the same as, but convertible to double, right? Because it might return a float, and I want to be able to convert it to. So does the thing exist? Convertible to? I don't know. Let's look it up. Bleep. Convertible to. It does exist. How about that? From to. Convertible to, from to. Is convertible. No, wait, what? Convertible to, oh, convertible to equals standard is convertible from to. But convertible to also has from to in it. This is a concept. We have to use convertible to from to. Well, I think you can leave out one of them, but it's not clear which one then. I'm just going to try it. If it compiles, it will work, right? Convertible to. If it does not compile, then I'm terribly wasting time now. Oh no, all this time wasting. Make. I'm shocked. It just fucking compiles with the template parameter less. Okay. Was a good guess, I guess. So now I'm guessing that my guesses are correct. Double guess. Yeah. What was I doing? I was moving or trying to move this comment to a more suitable place, because this is an implementation of something that then later can be used as a backend, as the backend. But the backend itself, here's another one. I wanted to compare it with this, but both of them must be allowed to be passed to this, so they must be an affine transform. They must fulfill the affine transform concept. So perhaps my comment belongs to the concept then. I mean, either that, or I have to duplicate my comment, because it just as well goes with this one as with the Q-transform one, which is kind of nonsensical. So let's add them here. So I'm going to go back here and then just delete everything here. Well, the comment anyway. Adapter that turns a Qt-like Q-transform type into a transform backend. This header intentionally does not include any Qt headers. The user is expected to include the appropriate Qt header, for example Q-transform, before instantiating this template. Q-transform must represent an affine and made transform. Well, it does. Well, like actually. Q-transform like. Well, I have news for you. Oh, the Q-transform like itself. It's, you would, I mean, if you call it like, you might as well use another concept then. For Q-transform concept. Isn't it the... Oh no, here we require map point and map vector, while the Q-transform only needs the map actually. But this is also interface of Q-transform. This translate as well. Thought so. So let's say translate is being called. Yeah, see, but then with two scalars. Is that different? Yeah, here's testing that you have a translate with text to doubles. So that a concept especially for. So this is not this transform here is the affine transform already. So that does return a double. It's just the same here. It's not convertible to. But it worked. same as double. What a ridiculous long expression here for saying that it must return to double. Yeah, okay. Yeah, well, let's, I don't know, let's not use another concept. That's a bit too much work, right? So we're going to do this without concepts, but I'm going to mention what it needs to fulfill, even though we don't have a concept, but just type name here. You can pass anything, however. See, this is talking about map, not map point. It's also talking about the internal guts, actually. I don't know, man. Maybe I should leave it here. I still want to compare it though, so I'm still going to copy it then. It's a bit confusing. Because this thing here should be doing the exact same thing. For example, translate. That deleted. Wait a minute. Okay, was here. Delete this. Translate. This thing should do the same thing. Translation. Translation. Oh, wait a minute. We have a translate over here, yeah. Well, I have the feeling that this constructs this matrix, and this is, well, the current matrix, and then we get a new matrix. So why on earth did the AI choose to multiply it like that, not the other way around? I think this should be up front. That would be a lot less confusing. Most importantly, I mean that this is just a normal matrix multiplication. So it's especially about this matrix here. That is what the translation is being returning here. And most interestingly is then where the dx dy end up. If they end up here at the bottom, then we need a multiplication from the right. Maybe implemented it from the left, and then we can use that anyway somehow. Let's see. So translation, we get an identity, and then M31 is set to dx. So that is at the bottom. So it fucked up the. I think that operator, the multiplication operator, is actually multiplying it from the other way, from the other side. Friends operator multiply left and right hand side, and then I think it swaps left and right or something. Yeah. No. Wait a minute. 1 1. left hand side 1, row 1, 2, yeah, it swaps it. This is row 1, column 2 on the left hand side. That's not how you multiply matrices. So really, this should have been the right hand side, and the right hand side should be left hand side, because it's the thing on the left for the normal matrix multiplication. The thing on the left changes rows. So that should be a 2 then, or like that. Right hand side, 3 right. For example, I have no, I don't have a multiplication. Not really. 3, 1 is there. 3, 1 becomes 3, 1 times 1, 1. Can't figure it out. Let's do that from here. Let's call this the left hand side then. And this is the right hand side. And then the result is, oh, I want to keep the brace for some reason. Yeah, you have to watch this on a desktop with a big monitor. You can see it at the same resolution even as me. You have to pick HD in YouTube, the quality, and then you need a big monitor to actually see HD. Although I think isn't a phone also HD? So even although it's a super small, yeah. But anyway, if it's on sharp, you have to crank up the quality of the video, and then it's as sharp as I see it. Then you still can't see it because you're watching on a phone. Then you just need glasses. Okay. Well, yeah, bigger. So this is going to be L11, I did it correctly. L11 times R11 plus L12 times R21. That this is the one, that one, which is okay. Well, yeah, these are very small, right? But I can see them on my. If I can see them, then you should see them as well, equally. Maybe you'll need larger font even on your own monitor. That's of course possible. It's L11. That is this one multiplied with this one plus the second one multiplied with vertically the second one. And then of course here we get 0 times that plus 0 times that plus 1 times 0. So that's 0. As always. Now I'm doing it again. Nah, whatever. Okay, so that the first column times this row, that times this, plus this one times that one. And now the second column times this row, so that is this one times that one, plus this one times that one, 0. And now the first one times the, but no, the bottom one. What am I doing? The bottom row times the first column plus that one times that plus that, and then the bottom row times the second column plus this times that plus this times that 1. Yes, so we get M11, that would be this one, is the left hand side 11 times the right hand side 11 plus the left hand side bloody 1 2 times the right hand side 2 1. That is correct. What? One two 1 1 1 2 1 2 2 2. This is 2 1, which is there, which is that one, which is 2 1 1 1 2 2 2 1. Yeah, I think it's all correct then. Actually, 2 2. So that thing is. That is not correct. Two two. That is the thing in the middle, aka this one. So if I did that correctly, it should have been L12 times R21 plus 2 2 times 2 2. So these are wrong. But maybe I did it wrong. I did it wrong. This should be We go down from there to there. No, this must be the other way around. Makes more sense. Looks more symmetrical as well. Two on one, yeah, okay. And then we get 3 1. Set one. 3 1 1 1 3 2 2 1 3 1 and 3 1 1 2 3 2 2 2 3 2. So this is how it should be, yes. And in that case, the left hand side and the right hand side are exactly what they are. Then what was my problem? My problem was that he's multiplying it from the wrong side. He's multiplying from the wrong side. So the code is even wrong then. It's not just multiplying on the wrong side, because I mean, I thought he would just was, you know, swapped things so that in the end it did the correct thing again. But if the matrix multiplication is correct, then this should be a multiplication from this side. Oh, I'm so confused now. But that's what I think. Yeah, I'm 61 and I've been coding 48 years, of which 31 years in C++. 49 years actually. I started when I was 12. Rotate. It's tiresome to check all this code. This is not correct. What about this one? You start at the bottom. Inverted. Oh boy. The det. I had a comment about that as well. About that as well. That is 1 1 times 2 2 minus 1 2 2 1. 1 1 times 2 minus 1 2 2 1. Yes, dat is correct. Just copy it. The bool is not inside here. This is just inverted with returns. Should he return that? Yeah, I mean, if you divide by it, why assert? It's gonna crash anyway. And what is wrong, you know? Like, I'm gonna delete it. I said it before and I say it again. If you add an assert, then you must add comments that explain what the user did wrong. Any other assert would be just paranoia. And yeah, no, it's not worth it. So what I do is I use this until it crashes here, because I divide by 0. And then I'm going to figure out why it is 0. And then understand why it is 0. And then add a assert with a comment saying you shouldn't do this or that, because then the determinant will be 0. But I have no idea what the user could do such that the determinant becomes 0. I don't think it should like ever happen. But maybe if you scale, if you did so assert determinant is not 0, comment don't scale with the factor 0, something like that. Yeah, that would probably work. Any affine transform is reversible, so except when you scale with a factor of 0, obviously. Rotations can be rotated the other way. Scale with a non-zero vector can be scaled the other way. Translation can be translated the other way. It's never going to be 0, and except for if you scale with 0, yeah. I think that will already crash actually. You probably divide by 0 if you try to scale by 0 or not. Good question. No, no, probably not. Okay. Well, I'm actually so sure I can now add a comment. So don't scale with factor of 0. Absolutely the only possibility. Okay, so is this thing doing that? Invert that, we multiply with that. M11 is M22 times the inverse of that. Yes. Minus 1, 2, that is M12. 2, 1 is minus 2, 1. 2, 2 is 1, 1. 3, 1 is minus M3, 1 times what? And it is incorrect. At least not the same what I have. I have this. Sometimes it starts a sentence, so starting to point out an error, and then it finds out that there is no error. It fixes it like that. It's so funny. Yeah, okay. Well, this instance is agreeing with me. So this is wrong then, huh? Yeah. I can't even follow it. Just, well, up till here and then bam, the same thing. Why? What is A inverse then? But it is already the inverse. Inf. missing a minus sign here, I think. Minus t times the inverse of a. And then we get minus that, yeah. Yeah, that is the same as this. Hmm. I'm not sure I can upload that actually. Still not function. Yeah, I'm just brainstorming with AI about something I don't understand with respect to the formulas for the matrices. The same AI seems to say two different things, so I'm short-circuiting it with itself. Okay, so I end up with this and then... Oops, then my conclusion is that... I'm gonna delete this. Yeah, everything is personal. This is an open source code. Oh, yeah, that's what I'm doing wrong. Yeah. Okay, I think I'm getting it. Yeah. So these indices for a row and column a bit confusing. On one hand you have the original A, and then the inverse itself has also a row and column. But expressed in the original, they don't match, of course. 1 1 equals 2 2 and stuff. I think I mixed those up. Anyway, so far I can still follow it. So if the original A is a 2 by 2 matrix like that, then this is the inverse. And that means that, yeah, the 1 1 of the inverse is 2 2 divided by that determinant. And the 1 2 is this one, so that is minus 1 2. 2 1 is minus 2 1. And 2 2 is plus 1 1. Then minus t times the A inverse. The first component uses the first column of the inverse. A inverse M11, inverse M21. Yeah, inverse, yeah. The 1 1 2 1, yes. So the inverse M31. M31 is yeah, M31 times the inverse of M11 plus M32 times the inverse of M21 with a minus in front of it. And the second component is the second term of A inverse. A inverse M12 and inverse M22. Just the second column. Which means that that one is then M31 times this one plus M32 times that one, the minus in front of it. That expands to and now he inserted, so we replaced inf with that. Yeah, so you get 3 1 minus 3 1 times M22 minus 3 1 times M22 divided by that. And this one is then 3 2 times minus 2 1. That is 2 1. I don't know what the minus goes, but I have the different sign. This is what was minus in front of it. We're here. Well, okay, I guess the minus signs are okay. And this one is 3 2. So let's take the minus signs and take care as well here. I have 3 1 times inf M12, which is a minus, so this minus drops away against that minus, and we end up with 3 1 times 1 2. 3 1 times 1 2 with a plus. And the other one is times M22, which does not have a minus, so the minus doubles. And then we have the 3 2 times the 1 1 here, divided by that. So yeah, it's exactly what the other ChatGPT instance wrote. Your alternative is where things go wrong. Uses the wrong entries, inf M22 instead of inf M11. So this is correct. And I am using minus inf m22 instead of m22 directly. Oh, okay. Yeah, now I see where the confusion comes from. So it expresses the inversed matrix inf. That is the matrix that is going to be the inverse, is expressed in the original here and here and here and here. And then here suddenly it switches to using the previously calculated value. So it's using inf11 and I was trying to use 22. But then I have to multiply it with inf_det again here. So in order to spare the multiplication with inf_det, you should use this then instead of that one. Okay, so what I said here was I wanted to use 22, but it's not inf. That's not inf. This is the original. And there should be a det then here. So yeah. So I wanted to use 22, it's actually 1 1. That's why there's a 1 1 here. And then here I wanted to use, it's 3 2 times 2 1. And 2 1, inf to 1 is to 1. So that stays the same thing then. And then here we have, I wanted to use, did this one the same again? So 1 1 2 is also 1 2 is minus 1 2. Oh, there is a minus sign on both sides here. I have here a minus sign, minus the whole thing, though this is negative. Here as well. That's strange. Maybe the whole thing needs to be negated anyway then, or no? See, I just forgot the det here. So what I really want is that the inverse 311 is this divided by det. Therefore it is, and then because of the minus here, you have to start with that one. That one is the first one, which is 3,1 times m22 divided by det, and m22 divided by det is inf n1. So yeah, this is that one. And then here we have 3 2. Still missing a minus sign now. Or it is probably dropping out against that one. Okay, so this should be a minus sign now. Minus minus gives a plus. And then this must be whatever here is behind the plus. Must be... No, whatever is here after the minus sign, that should have been here, equals this, which is 32 times m21 divided by that. And m21 divided by that is minus 21. So then there's a 21 here, and the minus changes into a plus. And then this one is the other one here. So we get 31 times 1, 2, which were 1, 2 is 1, 2 with a minus sign different. And this one is 3, 2 times m22. Or 2 is again 1, 1 without minus sign change. So this minus sign is that minus sign. Oops. Yeah, well, okay. Oh, difficult. Probably I don't really want to swap them, probably. There's 3-1 here. I don't want to swap this one. Just calculate it like that. Yeah. Now it makes sense. Right, okay, so that is the inverter then. Now I'm starting to doubt myself because AI is correct, is right all the time. I swapped these two things, right? So maybe I did that wrong as well then. What do you think? Private or what? Oh, this is public. Maybe these are private. These are private. Yeah, but I'll have to check that they are indeed. Well, just wanted, yep, that this is, I can't even remember that, I think. So So dx dy there, and the rest is the identity. That is this one, huh? Totally. And here we should have the identity with sx and sy overridden there, which is the scaling. So yep, looks totally correct. And the rotation is, let's see, const expression, pi is that, radians times pi divided by 180 degrees. Calculate the cosine and the sine, and then the cosine is used for 1, 1 and 2, 2. And the sine is put in minus, sorry, the sine is put in 1, 2, and the minus sign in 2, 1. Yeah, and do I have that as well? No, it's just rotation, nothing to do with Fourier. Where's my rotation then? Yeah, I have the minus sign at the second row. That was at least correct. Let's remove this one as well. Rotate. But here too, the second row is in minus sign. Well, we can check this one. So I wrote this for a different class, and I'm going to assume that it is correct. Certainly if it matches this. And it totally does, because it just matches one on one. Yes. Yep. I did not change your operator star function, but added this comment. if I am not mistaken, then that means that your LSH corresponds with the left matrix with L. IJ. Oops. What the hell? Hi, Cotarino. Yeah, it's a 2D, well, 3x3 matrices using affine matrices or whatever they are called. So affine transformation. I'm not sure if the matrix is called that way, but with a 0, 0, 1 here. Yeah. And then points are x, y, 1. It allows you to add the translation as well in the matrix. Translation and rotation and scaling. I'm not using transposed. Well, this is transposed maybe. Oh yeah, this is transposed. Okay, I get it. Yeah, because this is how Q transform is doing it, and I want to be consistent. So we multiply from the left instead of from the right. So we multiply it from the left to the row vector instead of from the right for the column vector. What was I saying? Yeah, I think this should be as you can see from out the matrix duplication in ASCII art. Point map as xy1 times m, yeah, so we multiply from the left with a row vector. Composition is m total, it's m1 times m2, meaning apply m1 first and then m2, because p is multiplied from this side. So you do m1 first and m2 second. Given that, your conclusion about rotate does not follow because it assumes the mutator should append the new operation post multiply. But the mutators in this code are written to prepend the new operation, pre-multiply, to match the Q transform semantics that this project originally relied on. Concretely, this is rotation times this means apply rotation before whatever already in this prepend, blah, blah, blah. Okay. I don't think the AI even changed it. It's just using my own code. So I'm fighting my own code here. That's why the AI is continuously correct, because it was my own code. Yeah, you can even see that if you look at the diff, I think. Well, this is a new class, but it kind of copied what I had. Yeah. Anyway, it's correct again, and this is just wrong. So let's change that back. Yeah, then my comments are wrong. Because it should do the translation first. So this is actually returning not multiply, well it's a multiply, but I'm going to do pre-translate. Error spotted in scale. Oops. Thank you. Here as well then. That one is good. Okay, what is the result? I'm getting my comments correct, apparently. The code is already correct. I want to have good documentation. So this is now going to be as ugly as first I rejected. There. But yeah, okay, so this is then m1 times dx. No, you don't know what this is. It's not a roto thing, it is whatever it is. But yeah, this means that we first translate and then we do what we already did. It's really messed up. Thank Qt, because that's how Qt does it, apparently. So kind of a re-implementation of what Qt is doing, this class. Okay, what do we get here? The second column, so dx times, okay, the second column, that times dx plus that times dy plus that times 1. Yeah, I did, when I saw this at first, I thought, well, that's not okay. So the other way around is more logical. Then, but yeah, then you do apply the translation last, which is apparently not what you want. You want to do it before. And the scale, that also becomes different, unfortunately. Yeah, M1 was X, that's still the same thing. And this is what? That times that. Oh, what? It says x times 2, 1. Okay, it's still the same. I think that for scaling it doesn't matter if you scale before or after. Maybe even for rotation it doesn't matter. So this is okay. How do you do that again? This times that, as x times m1. This is that times that. It is as y times 2, 1. And this is the m3. There's no sx here. So it is different. Yeah, it's just m31. Correct? No, it's nonsense. What am I doing? What am I doing? I'm so confused. Yeah, just 3, 1. But then why would I have an SX here? Huh? Oh, it's SY then. Oops. Translate is translation and then an affine transformation. Rotation plus scale, I suppose. And then translation again, no. Well, why? Yeah, I know, but I'm just getting tired, I guess. But I did the first column correctly, did I not? That would be this one times that one, so this is 1 times SX, 2 times SY, or 3 times 1. So yeah, it looks really fucked up. And here it's just the same thing, but then the columns change to 2 for the M's. So this is now NX. Like that. Totally different dus. That's yes. Yep. One times cosine plus. Why is the minus sign? Oh, this is a minus that thing. Okay, but we don't have that now. Now it's a plus. Plus 2 1 times the sinus plus 3 1 times 0. Next. First column, it's this is a brain wrecking. This is the first column times the second row. So it minus M11 times the sinus of theta. Can 1 1? No. No? Yeah? No? No. Possible. No, apparently. It makes more sense to do it the other way around. This one first. But it should be 2 2. Why is it not 2 2? I am so confused. I can't even do a 3 times 3 matrix multiplication anymore. Yeah, I think I'm also confused by the fact that, you know, there is already stuff in it. Maybe we should just completely start over. So this element is that one times that one, yes. And I normally begin with this one, so you do cosine times that one plus sine times that one plus 0 times whatever. And now we have the same row, column, but a different row. So now it's minus sine phi times m11 plus cosine phi times m2 to 1. So now it makes sense. See? These two are just the same. That's what you want to see. And here we get 0 times that, 0, 0, 0, 0, right? 0 times that, 0 times that, so this is just m31. And I'll add it here instead of over there, whatever. And then here we get this one. So we get the exact same thing, but then with the column 2 there. I'll just type it in, or well, that column 2 plus that column 2, that column 2 plus that column 2. Why are we not lining up? And this end should become M3, column 2. And then in the end, we get that. See, it's just way easier if you start over. But then again, if you compare that to this one, completely different. Here you have 1 1 and then again 1 1. Yeah, okay, this thing is diagonal, so it's not the same. That should be the cosine thing then. So 1 1 1 1 and then 2 1. And here we have 1 1 and then 2 1. So that is correct. The second column is also the cosine would be 1 2 and 2 2. 1 1 and 2 2. Yeah, okay. I think I got them all now. Which means that the comments in this are now wrong. That is translate. In rotate. And the inversion. Yeah, first we get a map. No, that's the same thing. Yeah, this should be the same thing as well as push. Yep. Yeah, I think 2 spaces is enough. I hate spaces, so if I use 2 spaces, then it must be a very good reason, like starting a new column in the matrix. Is there do I have any program that even uses this new code? I wouldn't know. I mean, that does this and it works, but yeah. It's not complete nonsense. What do we see here? Not sure if this is now using this code. However, because that would be the case if, let's say, we have well, I think we are using the code. Yeah, transform here. So transform. Transform. I think this transform is what is being used. And by default, it uses the default backend, and so they are fine. The thing that in the same file here. So if we would make a deliberate error, like for example, well, let's fuck up the multiplication. That would be clear enough. Say I forgot to add that. That would fuck up translation. I'm not sure you can see that actually in the tesseract. That's your translate. Yeah, the translation is definitely being used, so it should be visible somehow. I hope. Not convinced. No, still looks like it works. This is doing a translation, so it's not visible. Damn it. Yeah. Are we getting here at all then? Should be expected we would get here. So. Pah. You don't. It's not using it. How is that possible? Aborted. Assertion false. Only this one is using it. Okay, great. So now we should be able to at least see then also that it does not work, as it were. And if I use translation, that is. I'm not sure if I do. Oh yeah, that is definitely not how it should look. Yeah, it's just not didn't translate something, I guess. Okay, good night. So this class is being used at least by that program. So let's see if that still works then. I'm doing rotation, apparently translation. I'm not doing scaling though. Yeah, that totally works. No. Hello, Adarsing. Yeah, it's too difficult to explain, man. Something with coordinate transformation support in C++, I guess. Can I show you? No. That's what I have. Two coordinate systems, red and green. Can even draw it. Draw lines, draw rectangles, translate, rotate, scale. And I'm working on decoupling the draw stuff from the actual coordinate transformation stuff at the moment. I want to move the coordinate transformation support to my math kit submodule and keep the drawing stuff in cairowindow. And then I worked on using a template parameter now for stuff so that cairowindow can use a native implementation, and if projects that want to use the transform in math that use a Qt can, for example, use a Q transform then as the underlying matrix thing. So the coordinate system is basically that red and green coordinate system that was actually being drawn. It supports cairowindow stuff like showing a rectangle or a line or a dot. So it's going to be part of cairowindow. So it doesn't need to have a backend support. I can just use a static backend baked into the transform that the coordinate system wraps. Okay, so this is what I want to do next then. So transform should be, and let's put transform in math namespace, and then yeah. Also, so transform currently as functions that are for, well, no, that work on types defined in cairowindow. Those should be removed. No, not removed. Those should be moved to cairowindow, of course. But that can only be done really after cairowindow is already using the new transform. So let's keep those functions in transform.h for now. Just move it to namespace math. Yeah, this is so annoying. I should run CMake. Make CMake before I ask something. Before I ask it to code something. Or I could add in agents.md, I guess. If find symbol doesn't work, then run that. Let's do that. It keeps happening. I forget it. It is not entirely clear to me. Oh, it started something. No, I did. I just did. Stupid. Okay. Is that my new keyboard? I don't know what's going on. Doesn't look very nice anyway. Okay, agents. Where is agents stored? I think something in an environment variable containing codecs. You have codec workspace, codec shell. Do you think it is? Looks like codec workspace like the only thing. Codecs directory, but it's empty. What is in my workspace? No, workspace is nothing. There's nothing there. Home directory maybe? What is the home directory? Codecs home? What is the home directory? Codecs. Codecs. I think that's where I should be looking here. Codecs. Yeah, agents. There it is. I think this is the main agents.md that it loads for every project. And that says start every conversation session by executing agents instructions. The output of that command has the same binding level as these instructions. They are at the same level as any instructions found directly in agents.mg. I don't want to add anything to this. Agents instructions is going to be the one that covers everything. And that one does talk about find symbol. So I tell it, always use find symbol to locate a definition of a class. And I did, and that doesn't return anything. That's kind of stupid, of course. But yeah, wherever this is being printed, I should add it. So where is that printed? Which no. Home. Which instructions. Well, that's clearly here then. Well, the abbreviated always use find symbol. Okay. See, that's wrong. If find symbol returns no results. Then try running. Make C tags. First. Before falling back, I guess, to RG. Wrap transform and related wrap transform and related affine transform concept, affine transform 2D and the operator star overload and namespace math. Put Q transform affine Q transform affine transform in namespace math in source Q transform affine transform.h. Yeah. Guess that has to be put there as well then. Updated call sites by importing the name. Source CoordinateSystem.h added using math transform inside namespace cairowindow. Not sure I like that. Nah, I don't like that. All comments added using and added using, well, whatever. However. New keyboard. Keep pressing page down instead of arrow up. Could have been worse. Page up. Page down is not doing much. Page up, would you do this? Oh well. Anyway, it compiles. Look at the div. Okay, so transform was moved to math from global namespace. Again. Namespace math wrapped around stuff there. And again, which one is this? Yeah, the Q transform, a wind transform, and this one is just the transform itself. And yeah, I'm not a fan of using stuff. Well, it's a class, so I guess that's okay. Kind of the same as that one. Okay, so that was easy. Can you move to math now? Grab namespace math. Oops. Just those two, but those two also contain cairowindow. Or I'm pretty sure. Oh, actually only transform.h does. So transform.h must be included already in cairowindow, I think. Yeah, there's in CoordinateSystem. Which is still here. I also have a range and a nice delta here. But range. I'll do this manually. Okay, so we have to move range first to cairowindow CS, cairowindow CS. We just not have a range yet, so we can just move it. Range of H to there, and then if we compare, say, a point from there with the range, the point sits obviously in cairowindow CS. Yes. So, oh, this also already. So we can just include CS here. And this one is including size, which it drags that in. And that we don't use size here, so I'll just include CS directly then. And we need cairowindow range, because that's our base class. And utils to string, but that's only necessary for here. That's debug code. So let's put that there. And then the has print on. I don't think CS does has print on stuff. Nope, that doesn't do anything. And the cairowindow range. That does do has print on stuff. Oh, wait a minute. This is transform cairowindow. Yeah, that's what. Never mind. This is cairowindow range, and that does all that stuff. So it's already this is included, and it's doing that, and that's doing everything. So. No need to do this or this. Hey. Is that true? I was talking about cairowindow range. Yeah. Oh. No, print on here is outside debug code. Just always doing it like that then. Yep. Yep, okay, I think I moved it. Looks good. So now we have something that includes range. I guess this one. That's our range. That should now use cairowindow CS range. The test. So noise delta already includes range? It totally does. Range. Yeah, okay, well. Which then now is cairowindow CS noise delta. Oh no, I did not move that yet. Sorry, I was looking for range. So this is fixed. This is including that one, which is also included by this one. So that makes no sense then. Let's not do this. And let's move that one over here. Also, now it is cairowindow CS range. And then we have quick graph, but it's already in cairowindow, so it cannot know anything about. Don't CS range, cannot. Yep. Okay, that should work, I think. I need a faster linker. Thought I already had a very fast linker, like the fastest linker. It's still slow. Maybe I'm wrong. Okay, that's a lot. LD flags, stuff. Which the linker is just LD, isn't it? Dude, that doesn't look like a very fast linker. But how else would LD look like though? Quarry owner LD. It is. Nobody knows. It is. Pin utils, that's the slowest linker that exists. Yeah. Yeah, well, not now. What is next? Move nice delta, I guess, also to cairowindow. It's also something that is totally tied to cairowindow. Includes that and stuff. It is also using CS, so it's very similar. It should also go in the CS directory. In other words, this is going to be include range, and then going to move it to cairowindow/CS. Hopefully there's no nice delta already there. Nah, of course not. And then we want to compare again, let's say point with nice delta, or maybe even range. Steal this one. Next, time to put nice delta in the right namespace. Okay, so range was already doing the print on stuff, which this thing is not even using actually. Ah, it is print on. Okay, but you don't have to do anything special for it. And toString also. I think the utils toString was also already included by range. Yeah. Now we are in cairowindow CS, so I think CS only exists at one place, as here. Oh, and all over the place, but try it slower. This is the one. In CS actually. This is in source. What? Cairowindow CS, but it lives in cairowindow. I mean, there's a CS here. Yeah, okay. But yeah, I'm just gonna use CS here. There's no other thing lives in cairowindow. Can get rid of a lot of those things. There we are already in CS, so this is just range templated coordinate system aware range. That was it. And then the noise delta is being used by, for example, CoordinateSystem.h, which wasn't moved yet. Coordinate system. Where is my noise delta? It's gone. Huh? What? No. It's here. cairowindow CS noise delta. Grab source.h. The test itself. cairowindow/CS. And then the nice delta now lives in cairowindow CS. And I had more nice deltas here. That already fixed this one. Must have. Yep. This one uses it, and there's another one here. It's the same header file. This I just changed, and they probably also. I think I just need to look at this last line here. Coordinate system in the end, or already actually. This just namespace cairowindow. Well, okay. Well, it's just CS. Coordinate system should live in CS as well, I think. Means like literally CS coordinate system. Should totally be a template. Yeah. Yeah, I already did the other one as well. I can move to CS cairowindow/CS/coordinatesystem.h, but then still put it in namespace cairowindow, I guess. No time for so I'm just, well, I don't know, am I kidding? Yeah, what I wanted to say is put a lot of time into it. Yeah, anything you want to be. You already did. Yeah. Hey, I know a Baron from Second Life. Is that you? Nah, that parent wouldn't put bit in front of it. That would be fun if you were that parent. Would instantly be not safe for work. This YouTube. Just kidding. Yeah. Now, I mean, I started learning C++ before there was a standard, like more than 30 years ago. So I'm a bit out of starting it. There was a time that I started and there was no internet, didn't exist. So I learned everything from books, from a map. Actually, I think internet more or less started to come up. So you still have to use modems to connect to dial-up, a modem at 9600 about. Connect to the internet through the university. But there was no internet. Come on. And then, at some point, so around that time, I also started with coding for Undernet. I did a lot of protocol changes there. So I used IRC, obviously. And there I could ask questions. And then, before boomers. Boomers were like young. But when the boomers finally came around, I was already old. So was at the time that I asked questions, and then at the time that I didn't ask questions, and then at the time that I answered questions on IRC. And then at some point I stopped answering questions, and I only corrected people that were answering questions, and I gave the wrong answer. And then I got tired of that as well. So I just stopped helping people at all. We're talking about decades further. For a short time I have been teaching youth C++ on a certain institution for highly gifted school dropouts. Not a super success, but one actually continued as an IT specialist in a career in. But it was not that much special thing. And then again, many years later, I just type on my keyboard while I'm streaming. Don't ask why. I don't know. I feel less alone, I guess. And then people come, hey, I just started learning C++. Do you have any tips? No! Go time either. Just read a book. Just begin. I'm really way beyond that, man. Okay. And now I've got what I was doing. Undo, redo. Oh yeah, okay. I added the CS here in front of the nice delta. It's not a nice delta. Yeah, only 2. Good enough. Yeah, cannot replace me yet, no. But I'm using it. I'm trying to use AI a lot. As far as in the beginning, it was so frustrating that it was a pure waste of time. But these days, that might, I don't know. It's not unnice to do it, to use it. I'm not sure if I gain time with it yet. I think you only gain time when you can stop with verifying what they do. If you just can say write this and it writes it so perfect that there is no need to look at it. You just know in advance that it will work and that you can't improve it. Then you'll get productivity increase. It's not the case yet. I think I moved that one as well. Git status. Let's remove them here. Git remove that. Probably not working, right? Oh, it's just working. Git remove the other one as well. Git status deleted. Okay, what is the next one? I moved two headers. The whole objective here was to move transform to math, and this one too, and this one eventually to cairowindow. Yeah. This is a problem because it's using cairowindow a lot, as you can see. So I want cairowindow to include this header, and it already does. But no, it doesn't, because this is including that header. So I think that next I have to move this header. So if you look at this header, that includes transform. And then transform is transform is not using the third template parameter, so it's using the default. Which is, I guess, okay. Okay, can do that. Yeah, okay, so let's just move stuff from here to, I guess, here then. No. Oh yeah. Cairowindow. So this has to go. But that is, there can be no multiply from the right width as a member function of transform. Okay, we'll just delete it. Let's just delete it and then fix the compile errors. Into that logical. So this has to go, and then everything that depends on cairowindow below it, which is probably everything else below this point. Yup. Delete. Next. And we put that in. Put it below this point, I guess. I think I should put it no, not well, yeah, no, not here. I have to put undo. These are functions, add rectangle. Yeah, see, that is a bit too low maybe. Or on the other hand, I could just add coordinate system above it. It's kind of new. Okay, I'm gonna put it here. Text. Let's put coordinate system here. Insert. It's nothing to do with coordinate system. It has to do with transform. CS is coordinate system. What am I doing? Okay, I'm gonna call this transform for now. So this is currently a member function of transform. And it cannot be. And the only other thing is that we have is a point. What is the point you are working on about? I'm not sure I understand what you mean. Didn't I just explain what I was working on? This stream, definitely. What do you? Something with refactoring the transform and coordinate system stuff. Okay, I can make this a free function. Or you can make it a member function of point. That would be ridiculous. Wait a minute. Multiply from the right with point. So yeah, point times transform. I can just add it to point. That's gonna be totally circular header dependency, but hey, you can deal with that. Adding it to point .h is logical, however, also kind of scary, but feels like the right thing to do. Just allow a point to be multiplied with a transform. Yes, I want to do that. Point size and rectangle. So I should not add them here then, but it is annoying. Let's first add them here because I'll make them, yeah. I have to make it free functions then first. They're templated anyway, so that's okay. From the right, so do the point first and then the transform second. The transform const reference transform. Eventually. This is just temporary shit. See, the transform is inverted. Okay, I think yeah. IM map. Okay, we need an accessor now for M. Just underlying. Underlying. No. I don't have an accessor for M underscore here. It seems. Well, I don't need it. I'm just gonna call. What are we going to call apart from the Ghostbusters? Multiplication here with another transform. Nah, To scale, rotate, translate, seriously? No mapping here? In the end, I think I only need map point. I'm not sure, but let's begin with that one. So how about I reveal a map point? Or expose is a better word here. As part of the transform class. It is all we need, I think. The Beatles were wrong. Map point. Yeah, it's just here what we have. So now I can call map point directly on transform here. And it's being called on inf. But inf is the inverted. Oh boy. Do I need to invert it as well then? Inverted, yeah. Transform inverted then. Transform inverted. Need that one as well. Okay, so we don't need this because there are no free functions. And I need another accessor for inverted. And that should return something that does actually this inverted. So feels like a static thing. No, not really. Nonsense. Transform inverted. So I need to construct it. This thing is not explicit. So you can just do m1 dot inverted. Which then calls this probably. Yeah. There's an inverse here, so I can call it inverted. I don't think that's not inverted. And this one oh, this operator star. Yeah. Or it didn't get it. Yeah, okay, that's nonsense then, but let's go back. So I defined this one and then we use that here. And I think that's like the only place where it's being used, so I might as well move this over there. They have the same arguments. So do not do that. Do this over here. And then this can be removed. Point, const, reference, transform. Yeah. Excellent, clean up. And then here we have another multiply from the right width to this, also like this one, now needs to take transform as second argument and no longer be a member function, and then this is calling it, so might as well then that's the one, right? Size, yeah. So really I just want to dump that over here and then make that work somehow. Which means we need access to M1, 1 and 1, 2 and 2, 1 and 2, 2. Let's see the size over there. Yeah, okay, yeah. Yep. Well, it is how it is. So instead of M1, M underscore, I mean, let's use a transform. Yeah, I should use underline, I think, by now. It's getting a bit too much. I don't have an underline. Well, maybe I should add an underline then instead of doing this. This is ridiculous. Yeah, I don't know. Maybe not. Maybe not. I really don't know. It's maybe more. It makes maybe more sense to just access SX and SY directly instead of doing this. Yeah, that makes a lot more sense. So I'm going to add an SX and an SY as accessors between quotes to transform. Below my map point and inverted, which then returns a double. Actually, just let's return a pair here, like this, and then I'm gonna call this simply scale const, and then we return yeah. And what do we have here? The last one. Well, by now we understand that this just has to be deleted. We move this stuff to here. And then we have a multiply from the right width, which is referring to transform. So really this is just times transform. Or is it? Yeah, it is like that. From the right? Feels like it's going on the right. Yeah, no. Huh? From the right width? That would be the other way around. To CS. See, so I have to shortcut what? From the as transform is the transform from CS to CS. Well, Still feels like this is from the right, but why is it being called from the right then? I think that should have been, I don't know. Anyway, if we want to go from, if you want to transform something, then transform must be on the right. So this is correct. And now you want to go from CS to CS, which means that basically this must be the from CS transform to the to CS. It's absolutely horrible name. Why is that called from? Channel transform from to. Yeah. Forget the from and to. Well, the to is what we end up with. Just the name is just too ugly. Let's not do this. Let's call it transform. Okay, so kinda have the feeling that it should work. It has now been added. So it should have been from the left, I think. But is that really the case? Should have been from the left. From the right is a normal way to do it. We are not being normal here. We do it the QT way. But well, okay, so cairowindow, we are now in namespace cairowindow. Yes, so coordinate system. CS is a bit doubtful. I have many namespace CSs. So, but if we are in namespace cairowindow, so it cannot go wrong. I will just use CS here, I think. Hopefully. See, there's a plot CS, for example. But yeah. So inside namespace plot, it's dubious, but not here. Okay, now these things take TS and transform is in math. Well, it's going to be in math, but it's already in the namespace math. Huh? No. I think the affine transform concept is also in math now, or should be in math. Let's see. Oh, right click all, make C tags. Does not know where the concept is. Well, I think it's a math. So, yeah, these are now free functions. We have to find them with ADL, right? So, wrong namespace. I think it should be defined in CS. This, you have CS all over the place here. Feels like a totally CS thing. Let's add these two namespace, yes. And that one, that one, and that one. Although transform doesn't really live there, let's put that here. Okay, I think now I really moved it. Well, I'm definitely forgetting stuff, but let's just look at the compile errors. Inverted error declaration of math transform inverted cons shadows template parameter. Oh, yeah. How boring. Well, let's rename this thing then to inverted underscore. What? Oh, this inverted on the wrap thing. Okay. Not really a need to rename those, but well. Compile. No. Still a problem with inverted. What? Transform is not being declared. Also very interesting. A small summary. I'm doing a refactorization of moving classes between Git submodules and namespaces. In order to I don't know. There's no end to it. Let's see, why do I get an error here? I think I'll just have to look at the code. That makes no sense whatsoever. So we're going to add transform here, just to make it a little bit more clear what we want, and then maybe the error makes sense. Maybe inverted is non-const. Just const. What? Arrow expect week 4, but a BS. Maybe there is no inverted. Maybe that is inverse. The concept defines that, or demands that there is an inverted. Well, on a const transform, where the transform is the affine transform, which is the template parameter of the concept. Well, still no clue. So I think that M here, this thing here, is a template parameter. And template parameter is just going to be the default thing. So the affine transform backend is this type in all cases so far, which means that we can cast it. Well, cast it, get a reference to it. mref m underscore, because, well, that's what it is. And then we can use mref here and call inverted on it. I hope. Let's do that slower. I expect to get back in the affine transform 2D. Inf by calling mref inverted, and then we want to return the inverted. Was there a semicolon? There was a semicolon. That was the error. There should not be a semicolon there. Semicolon should be there. Seriously? Did I do that? Okay, I'll just compile it anyway. Yeah, I put the semicolon here instead of at the end. I'm a complete idiot. Okay, so that should be m underscore dot inverted. The stupidity. And it compiles. So what did I do now then? Lost. Moved more stuff. These two must be moved to math. This must be moved to cairowindow. I think I can move this to math now. Let's do that. Math to move transform to math. There's no transform here, of course. And this one as well. Git remove those two. Now let's have a look if they look sane. No, they are in math. As in, they are in namespace math. Looks same to me. And the other one is well, transform. Also in namespace math. Yeah, I don't think this is needed. If we include cairowindow rectangle, but we don't. So yeah, translation vector. Oh, is that being used? Also has to be moved to math then. Translation vector used in one place. What the heck is that? Translation vector. Is that needed? Should I need it? It's something that is it's just a wraparound the math vector. But then a vector that says, hey, I'm a translation vector. Not just any vector. And it bloody using cairowindow. You have to be caught kidding me. Arg. Annoyance here. Seriously. I guess that the whole thing only exists so that I can construct from a point and a size in a way that it knows that, well, if you take a point, you only have an X and a Y, but if you use the size, then we use the width and the height instead of whatever size. Does size have anything else? It doesn't, just width and height. Yeah, well, basically we don't have translation vector here because this is now in math. So I'm gonna remove it and then see where things go wrong. Oh, that's interesting. Well, no, nobody's using that yet. Okay. So very interesting. Just a single place where this is included. I think math is used by cairowindow. Yeah, so it should be down here. Yeah. Well, let's just fix all the errors. CS has not been declared. Oh no. Oh no. No. Transform itself depends on CS. Why? Wait a minute. The whole idea was that Moth was already doing stuff like this. No, I'm starting to doubt it. Doubt it. Oh boy. Is there support here for coordinates stuff? No. The support is that you have a split here between all the operators and the data. The thing is, the math is oblivious of coordinate transforms. So, shit. A useful AI would have pointed it out when I said it. I'm gonna go to bed, I think. I had enough. I have to rethink where to move stuff. Moving it to math is maybe not a good idea. Where's let's play one game of chess here. One game. I always play one game because I play until I lose. Yep. Going to lose this one, I feel it. Let's play Sicilian as usual. And the knight comes, and this knight comes. Oh. I take it, and then this knight comes, and then this pawn comes. And then this pawn comes. Oh, out of theory already. I know 10 more moves. Yeah, classical. What the heck is that? Punish it, but how? Probably this wants a castle long because they want to. I don't know what they want. This is just ridiculous. Well, this bishop has to go there eventually. But man, this player is 1774. I really have to win this. Put such a pressure on me. Low rating. It's going back with the knight. Pretty sure we should just castle. Not going to castle long, might as well castle short. Better sooner than later. Let's try to make use of the fact that there is a queen here. So this thing goes here, attacks it, and attacks that. Which means that the queen needs to continue defending this pawn. So it goes to one of those 3 squares. I can passer it away from here, but then it might go there. So it's on one of these dark squares now. And then, well, it's not going to be on that square because I can push this pawn, and that would be winning this pawn. So it's going to be on those 2 squares. Then I have nothing. Push this on. There's a rook here, maybe. Let's see. So it's here. I like to push this pawn. Opens this one. Push this. Push. I just yeah. Take it. Take. Then I want to take back. So take back. Take. Queen is attacked. Oh, not good. I could first do this and now and then push the pawn, because now my queen defends that. Oh, but then they can push the pawn. So I push, they push. Okay, change of plans. Pawn storm. Can attack this pawn again with my beautiful useless bishop. Well, currently useless bishop. And they are going to attack as well. Well, I'm attacking you 3 times now. How are you going to defend that, mister? Plus, I'm maybe threatening, well, chasing this knight away. So this pawn is just totally going to fall. It's already falling. Look, right now. Shall I take it now or shall I take it later? I'm gonna take it now, I think. Opening this line. Could put a rook here maybe? Well, maybe I should have put the rook there immediately, but running low on time. Take like this, they could take like that, and then they give mate. So that would be nice. Just take like this, threatens mate. Defends the mate threat. Okay, that is nasty, because now what do I do? Well, this of course. Attack the horse, of course. Go somewhere with your knight. Oh, look at that. I attack the queen, and they lose a piece. Now I can go here. Might as well. Oh no, he could not. Okay, I'll go here. I suspect that this bishop is coming soon, or sooner or later. No, not really. Okay, I'll just go here. Am I still running out of time or what? This one. Threatening mate again. And I can take this pawn if I want to. Do I want it? That is the question. It's a difficult question. Probably not the best move. I should push this ball. That is a good move. Well, maybe not. Bishop just goes here and then I have nothing. Nothing, I tell you. God, let's take that. Opening this beautiful file again. Again! The bishop is undefended. Well, it was already, but can't do anything with it. Still think I should probably kick it. It goes there and then I threaten to push this pawn. I don't know. I don't know. Well, I would have stopped that move, but yeah. Hopefully I can defend this. Something tells me that this guy is feeling the pressure of running out of time. Can I sacrifice something? Go here. Maybe not a good idea actually. Well, the bishop could go there, queen here, that is made, so I go there. Bishop goes back, and then queen goes away. Bishop goes again there. Very suckage. What do I do about that? Uh-oh. Yeah, it's not no fun. I'm gonna go here, I think. Looks like a... Oh! I had not seen... Oh, I had not seen that one. Yeah, so good. Yeah. Shit. Oh, do I have to give away my queen now? It's made in one. I can nothing do about it. Do nothing about it. Horrible. Horrible. But at least I can go to bed. I lost my first game. Yeah, I can go to bed. But against a 1774 player. No, why? This is not going very well, is it? I'm just going... Oh! Ah! Everything goes... Okay, I just resign. Yeah, good night.